So let's get started with this paper, which is S1, and it's February-March 2024, variant 52. So let's get started with the very first question. The question says, a bag contains 9 blue marbles and 3 red marbles. One marble is chosen at random from the bag. Now, the rules are slightly different. If the marble is blue, it is replaced back into the bag. If the marble is red, it is not returned to the bag. A second marble is now chosen at random from the bag, and then they're asking 2 parts out of it. So it's a one-page question, and then there are 2 parts. So now let me get my blue marker ready. First of all, there are 9 blue markers, actually marbles. And the rule is if the marble is blue, it is replaced back. That means the denominator won't change. But if we are talking about a red marble, and if we are choosing a red marble, it is not returned to the bag. That means this is without replacement. A second marble is now chosen at random from the bag. Find the probability that both marbles chosen are red. That means we are interested in red and red. Let's focus on the denominator. Since this is without replacement, the first denominator is 12, the next denominator is 11. In probability, always focus on the denominator. And what about the number of reds? There were 3 reds initially, so this is 3 out of 12. Since 1 is taken out, now 2 are left. So therefore, the answer for this one is 6/132, which can be reduced and can be written as 1/22. Now, it's not an instruction from the examiner to reduce it, so we can leave the answer in the raw form also. The next part. Find the probability the first marble chosen is blue, given that the second marble chosen is red. Now, this is the condition. The condition is second marble should be red. That means one option is this one, which is red, red. And we are already aware of this probability, that is 6/132. What is the next option? The next option is the first one is blue, the second one has to be red. Now, what is the rule over here? If we are taking the first one is blue, it is replaced back. So blue are 9, red are 3, and the denominator over here remains as 12. So this is 12 and 12. For the blue, we will write 9. For the red, we will write 3. And let's multiply it out. Let's keep it in the raw form for right now. So this is 144, and 9 into 3 is 27. That means the condition which goes down in the denominator, that is 6/132 plus 27/144. Now let me use a calculator and add it up. So let me grab my calculator, and this is a fraction 6, and then I have 132 over here. The next one fraction is 27, and this is 144. So this adds up to 41/176. This is 41/176. So therefore, let me draw a thick line over here. And in the denominator, we have these two, which is 6/132 plus 27/144, which will become 41/176. Why have I written it separately? Because I'm interested in the numerator, which is basically blue and red. So blue and red, that is the numerator. So this numerator goes up. That is 27/144. So this is 27/144. And when we divide, the answer that we get in the reduced form is 33/41. So that's how this first question is completed. A little more than average question, but it's a good one. The next question, question number 2. Now the question says, Sam is a member of a soccer club. She's practicing scoring goals. The probability that Sam will score a goal on any attempt is 0.7 independently of all other attempts. The first part, that is, Sam makes 10 attempts at scoring goals. Find the probability Sam will score goals on fewer than 8 of these attempts. Now, this first part, this is about binomial. So X follows a normal distribution, actually a binomial distribution. 10 is the number of trials and probability of success is 0.7. So we are focusing on the goals scored by Sam, and the fixed number of trials is 10 and the probability of success is 0.7. When we are interested in fewer than 8, we will write X is lesser than 8. So 8 is not inclusive. We will write X is lesser than or equal to 7, which is too much to calculate. So what do? We calculate the probability of 8, 9, 10, which is X is greater than or equal to 8. So let me write it out. This is 10C8, and then 10C9, and then 10C10. Close the brackets. Probability of success is 0.7. Let me write it in the second bracket. That's how I write it. Probability of failure goes in the first bracket. And this 8 becomes the power over here. This 9 becomes the power over here. This 10 becomes the power over here. And 10 and 8, the difference is 2. The difference is 1. The difference is 0. So now add up all these probabilities, put everything in the calculator, and then subtract from 1. And the final answer is coming out to be 0.6173. Write it correct to 3 significant figures. That is 6173 SF. So that is the answer for this particular part. The next part. Find the probability that Sam's first successful attempt will be before her 5th attempt. First successful attempt. Now, this is about geometric probability distribution. So let me write Y follows a geometric probability distribution. The probability of the success is the same as before, but it is geometric. There are no number of trials. And the key word is until, or the very first successful attempt. So before her 5th attempt, so probability Y is less than 5. That can be written as probability Y is less than or equal to 4, which if you want to, you can do the working for 4 terms, or you can apply the shortcut, which is 1 minus failure raised to power of 4. And that is based upon geometric series, geometric progression. So this is 0.3 raised to power of 4, which comes out to be 0.9919. This is an exact answer, so I'll leave the answer as it is. And also double check, if this is exact, leave it as it is. If it's inexact, then round it off. So 2 parts are done. The third part. Now it says V is a member of a soccer club, and he's also practicing scoring goals. So it's a different person now. The probability that V will score a goal on any attempt is 0.6. So it's not the same person as before. Sam was the first person and V is a different person. Again, independence, that is given. V is going to keep making attempts until he scores 3 goals. Find the probability he score his 3rd goal on his 7th attempt. Now, very nice question. Because it is a combination of binomial and it is a combination of geometric. How come? Let me draw a box. First of all, this box is for the first 6 days. And this greenish box, this is for the last day. So basically, for the first 6 days, since the 3rd goal will be on the 7th attempt, so the 3rd goal goes over here. And that success is 0.6. In the first 6 days, he will score 2 goals in any order. So therefore, this is binomial. So this one is binomial. So we will write X follows a binomial distribution, 6, 0.6. Probability X is equals to 2, that is 6C2. Success raised to power of 2 and failure raised to power of 4. So this goes over here. 6C2 is basically 15. This is 0.4 raised to power of 4, 0.6 raised to power of 2. So this is 15 options. This is 0.4 raised to power of 4. This is 0.6 raised to power of 2, multiplying with this. So now let's use a calculator, and this answer comes out to be 0.082944. I can write this thing as 0.0829, correct to 3 significant figures. So this is part C done. Question number 3. This is about a histogram, and then it's about mean, and then it's about the class interval of lower quartile, upper quartile kind of thing. So now the question says, the times taken in minutes by 150 students to complete a puzzle are summarized in the table, and draw a histogram. Now, before that, let me just do one thing. Let me take a screenshot of this table, and let me save it as an image, and I'll be using it over here. So it will be easier for me to have a look. So there is the table right over here. Okay, going back to this. So now we are interested in histogram. The very first thing that we should focus on, that is the class width. And even before that, are these boundaries? Yes, they are boundaries. It's ending at one number, starting from the other number. Yes, it's boundaries. So just do the subtraction. So this is 20, this is 10, this is 5, this is 5, this is 10, this is 20. What about frequency density? That is frequency divided by class width. So 8 over 20, that's 4 over 10, which is 0.4. 23 over 10, that's 2.3. 35 over 5, that is 7.0. 52 over 5, that is 10.4. 20 over 10 is 2.0. 1.2 over 20 is 0.6. So these are the values for frequency density. Now let me look at the grid. The highest value of frequency density is 10.4. So that means this is 1, 2, 3, 4, 5, 6, I think a lot of space, 7, 8, 9, 10, 11, 12. So that's perfectly good. So let me just draw a vertical thing for this thing. So that's a vertical grid. And that is perfect. And the horizontal grid is for 0 till 70. So let me first draw the line. So let me choose orange color. And this is 0 till 70. Now let me think about it. If this is 10, 20, 30, 40, 50, 60, 70, this is perfect. So now let me label it. So therefore, this is 0, this is 10, 20, 30, 40, 50, 60, 70, and this is the time. The time is in minutes. And the vertical axis is for frequency density. And let me just check one thing, which I always do. That is, the recording is on and it's all good. So now frequency density is there, and 0 till 20, this has a frequency density of 0.4. I need to label the y-axis first. So therefore, this is 2, this is 4, this is 6, this is 8, this is 10, this is 12, and 0.4 between this thing. That is 0 till 20. So 0 till 20, let me choose a color. And 0 till 20, it's 0.4. So this is 1.4 is very, very small. Okay, that's the first one. Now let me just do one thing. Let me just change the color of this. And similarly, let me change the color of this. Okay, now this looks better. So 0 till 20 is 0.4. 20 till 30, this is 2.3. So another color. 20 till 30, that's 2.3. So 2.2 is there, and 2.3. This is 2, this is 2.2, 2.3 is somewhere in the middle. Okay, so that's the next one. Now keep in mind, I'm just doing it a little bit rough. Okay, actually, it has to be a bit up. So let me just delete this. Let me do it again. So this is 20 till 30. Okay, that makes sense. So just ignore that overlapping because it's beyond my control. 30 till 35, that's 7. So now 30 till 35, that is 7. This is 4, this is 6. Over here, this is 7, I think. No, I don't need a curve. Okay, good enough. That is 7, and 35 to 40 is 10.4. 35 to 40 is 10.4. So this is 10, 10.2, 10.4. Okay, and the last one, no, not the last one. 40 to 50 is 2. So 40 to 50 is 2. And now the last one, 50 to 70 is 0.6. So 50 to 70 is 0.6. And that's how this colorful histogram is made. Let's move on. Calculate an estimate for the mean time for these students to complete the puzzle. So I need to write x over here. X is the mid value. The mid value of 0 and 20 is 10. And then the mid value of 20 and 30, that is how much? That is 25, 30, and 35. That's 32.5, 35 and 40, 37.5, 40 and 50. That is 45, 50 and 70. That is 60. And this is the frequency. So x bar, that is sigma fx over sigma f, which is 10 into 8, 25 into 23, 32.5 into 35, 37.5 into 52. Let me just go back to 52, 45 into 20, 60 into 12, everything added together. Just push it to the left. Okay. And now it's being divided by 150, which is the sum of all these. So now using a calculator, this answer comes out to be exact, which is 35.75. Now the next part. In which class interval does the lower quartile lie? So 1/4 of 150, that is 37.5. That means the 38th value or the average of 38th and 39th, or just the 38th value, that is the lower quartile. So 8 plus 23 is 31, 31 plus 35. This includes the 38th value. So therefore 32, 35. So 30 to 35, that is the class interval in which the lower quartile lies. Question number 4. Let's start underlining. A company sells small and large bags of rice, the masses of small bags. So we're starting with the small bags. They are normally distributed with such and such in a random sample of 500. How many would you expect to have a mass greater than 1.26? So just a usual question. First of all, write x follows, or instead of x, let me write s. S for small. S follows a normal distribution. That is 1.20, 0.16 square. Probability S is greater than 1.26. Probability Z is greater than 1.26 minus 1.20 divided by 0.16. Probability Z is greater than, and the Z value from the calculator is coming out to be 0.375. Now, some people they are interested in the detailed version of this. So let me just choose that thing which I have copied over here. That's like this. And over here, if I look at 0.375, so let's go to 0.3 and then 7 over here. So we get 6443. So we have 6443. And then I'm interested in the third decimal place, which is 5. So this value is 90. So 6443 plus 19, that is 6444 plus, actually 6442 plus 20, that is 6462. And then put the decimal place. Now, this is the value. This is phi of 0.375, but don't forget the rule. The rule is what? This is 1 minus probability z is lesser than 0.375. This is 1 minus 0.6462. Now do the subtraction, and this answer comes out to be 3538.3538. Just wait a minute. It's not over yet. We are looking for the expected value. So therefore, expectation is NP. That means normal distribution is for one particular thing. It's for 500 things. So therefore, this is binomial. So we take this 500, we multiply with 0.3538, and we get the answer as 176.9. Now, let me take you to the mark scheme for this one. And unfortunately, the mark scheme is not there. So now, whenever we are dealing with this thing, it's about an object. Maybe it's about a bag of rice or a person or an apple. So you have the option of rounding up or rounding down. So I'll just go ahead with the rounding up. So that's the answer for this part. So this is how this first question is done. First part is done. Now the next part. Now it says the masses of large bags of rice are normally distributed. That's the mean, and the standard deviation is unknown. 20% of these large bags have a mass less than 2.40. So now we will write L for large follows a normal distribution 2.50 comma sigma square. And the condition that we have as probability x lesser than 2.40 is 20%. So instead of x, I'm using the symbol L. So let's stick with that. Now, what we do is that we change the order and we write probability L greater than 2.40 is 0.80. So now, if you want, I can show it with a graph. And let me put the graph over here. That means there is a particular value over here. Let's say this is 2.40. And this area under graph represents 80%. That means if this is 80% and it's a realistic graph, because it has to include more than half of that area under graph, that means 2.40 lies to the left of the mean. Therefore, according to the rules of back solving, if I have a greater sign and this probability is more than 80%, because the normal distribution table has a minimum probability of 0.5. Therefore, we will take the z value to be negative. So now let me go over here. Let me choose this thing. And let me show you from where I'm getting this number. So now 80%, that is 0.8000. So therefore, let me just focus on this. 80% is 7995. So let me choose this value, 7995. This corresponds to 0.8 and 4. But 5 is missing. So go in this direction till you reach a 5. This 5 lies under 2. So this is 1 dp. This is 2 dp. This is 3 dp. Therefore, the z value is coming out to be 0.842 for 80% probability. So now it's not over yet. We will write probability and show all the steps. Even before that, you have to standardize. Probability z is greater than 2.40 minus 2.50 divided by sigma equals to 0.80. Let me just remove this 9 from here. Now, actually, I should have gone to the table after this step. So I got into a bit of hurry. I was more interested in the table, and that's what happens to people. So first standardize, then go to the table, write down this value, but now you have to give it a negative sign. So therefore, we will write probability z is greater than some value is 0.80, a negative, and this is 0.842. And therefore, negative 0.10 over sigma is negative 0.842. Sigma, actually the negative cancels out. Therefore, sigma is 0.10 divided by 0.842. And let me use a calculator. So the value of sigma, the standard deviation, is coming out to be 0.119. That is the answer for this particular part. So now this is done. The next one. Now the question says, a random sample of 80 large bags of rice is chosen. So first we were talking about in blue color, that was the small bags. Then we talked about in green color, the large bags. And we have this thing, just remember this 20%. 20% of large bags have a rice of mass less than 2.40. And this is rice have mass less than 2.40. That means we are interested in this probability of 20%. And the number of trials is 80. So let me write W follows, or let me write just X. X follows a binomial distribution that is 80, 0.20. So N, the number of trials, is 80, probability of success is 0.20, probability of failure is 0.80. Let me evaluate NP, that is 80 into 0.2, which is 16. Let me evaluate NPQ, which is 80 into 0.2 into 0.8. So 16 into 0.8, that comes out to be 12.8. And let me evaluate NQ, which is 80 into 0.8, which is 64. Now, first of all, justify, even if the examiner has not asked for it. So the justification is that why are we using the normal approximation? Because NP is greater than 5 and NQ is greater than 5. Once this is done, then focus on the mean, focus on the variance, and then we will write X now follows a normal distribution 16, 12.8. That is the little bit of extra working that you need to do. Now it says fewer than 22. So therefore, probability X is lesser than 22. Draw a thick number line and show both the options. So this is 22. This is 21.5. This is 22.5. Two options are there. There is this option because it's lesser, the red option, and then the blue option over here. Now, since 22 is not inclusive, therefore, we have to pick the red option. So therefore, probability Z is lesser than 20, actually one step before. X is lesser than 21.5. This is known as continuity correction. Probability Z is lesser than 21.5 minus 16 divided by square root of 12.8. Probability Z is lesser than 1.537. And this is direct reading. So you go to the normal distribution table just like you went over here. And this answer comes out to be 9378. This is direct reading 9378, which can be written as 0.938. So 0.938, that's the final answer, correct to 3 significant figures.
Recording in progress.
So let's look at question number 5. This question says, Anil is taking part in a tournament. In each game, players are awarded 2 points for a win, 1 point for a draw, 0 points for a loss. For each of Anil's game, the probabilities that he will win, draw, or lose are such and such respectively. The results are all independent of one another. The random variable X is the total number of points that Anil scores in the first 3 games in the tournament. Now, whatever I have read, let me write it down. First of all, in that particular order in which it's mentioned, it's win, draw, and loss. So win, draw, and loss. And there are points being awarded for this. So how many points for a win? That is 2 points. How many points for a loss? Actually, draw comes first. That is 1. And then 0 points for a loss. And the corresponding probabilities for win, it's 0.5. And then for a draw, it is 0.3. And then for a loss, this is 0.2. So let me just make sure that the colors are all good. This is 0.2. So now it says X is the total number of points that Anil scores in the first 3 games. So now if we are talking about the first 3 games and we want a total score of 2, how is it possible? What if I score a 2 and then a 0 and then a 0? So it is win, loss, loss. So let me write it down. So this is win, loss, loss. And then the other possibility could be a draw, scoring a 1, and then another draw that adds up to 2, and then a loss. So therefore, the other possibility is draw, draw, and loss. Now, first of all, I'll write it down. So win is 0.5, and then loss is 0.2, and then loss is 0.2, or this option is there, or this option, that is 0.3 into 0.3 into 0.2. But don't forget that you have to multiply this by 3 also. You have to multiply this by 3 also. How come? Because there are 3 options that are possible. It's win, loss, loss. It's loss, win, loss. It could be loss, loss, win. Similarly, DDL, DLD, and LDD. So therefore, you have to take care of all these options. Now use a calculator, multiply it out, add it all up. This comes out to be 0.114, and that's an exact answer. This thing is done. Let's move on. The next part. Complete the probability distribution table for X. Now, let us focus on getting a total score of 0, which is very easy. How can you obtain a total score of 0? So probability X is equals to 0 can be obtained if he's scoring 0 points in all 3 of them. So that is loss, loss, loss. They are all 3 identical alphabets. It's only one option, that is 0.2 into raised to power of 3. That comes out to be 0.08. So 0.08 goes over here. What about the next one? That is this thing, that is probability X is equals to 1. So probability X is equals to 1, that means a total score of 1. How can that be obtained? That can be obtained if there is 1 draw and 2 losses in any order. So DLL. So therefore, I'll write this as DLL and then LDL and then LLD. So therefore, D is, I think, 0.3 and L is 0.2 and this is 0.2 multiplying with 3 options. And this is coming out to be 0.036. So this is 0.036. So therefore, I'll write 0.036 over here. Now, as far as this one is concerned, that can be obtained from subtraction. So one possibility is add all other probabilities and subtract from 1. So that is one possible answer. Or let me work it out. So probability X is equals to 5. How can a score of 5 be obtained? There could be 2 2s and 1. So 2 wins and 1 draw. So this is 2 wins, 1 draw, and then WDW, and then DWW. So this is 3 into win is 0.5, and then 0.5, and then 0.3 for the draw. So let me just write it over here. So 3 into 0.5, 0.5, 0.3, that comes out to be 0.225. So let me write over here, that's 0.225. So that was a nice question, taking care of all the sample possibilities, sample space diagram kind of thing. Find the value of variance of X. Before that, we need to find expectation of X. So we have the formula expectation of X, that is sigma XP. So since this table is filled up, let me just grab this thing. And of course, I cannot do that in the exam. This is just what you can do right over here. So therefore, let me just write it down. Okay, no, not this thing, actually. It's the other thing. So therefore, I think I have this image. Okay, there is the image. So now let's multiply it out. So therefore, this is 0 into 0.08 and 1 into 0.036 and 2 into 0.114. 3 into 0.207, 4 into 0.285, 5 into 0.225, and 6 into 0.125. So now use a calculator, simplify. This comes out to be 3.9. That is expectation of x. Let me make a column for a row for x squared. This is 0, 1, 4, 9, 16, 25, 36. Now let me apply the formula for expectation of x squared, that is sigma x squared p. So again, 0 into 0.08 and 1 into 0.036 and 4 into 0.114, 9 into 0.207, 16 into 0.285, 25 into 0.225, and 36 into 0.125. Again, we have to use a calculator. This comes out to be 17.04. So just double check my working. And we have variance of x, that is expectation of x square, which is 17.04, minus square of expectation of x minus 3.9 square. And this comes out to be 1.83. Let me just double check it again. So 3.9 square, that is 3.9 square. And then subtract 17.04. This comes out to be 1.83. This is all good, all perfect. Now, question number 6. Now, question number 6 says, a new village social club has 10 members, of which 6 are men and 4 are women. So let me write men in blue color and women in red color. The club committee will consist of 5 members. So we are interested in selecting 5 members. In how many ways can the committee of 5 members be chosen if it must include at least 2 men? So it could be 2 and more, or it could include at least 1 woman. Now let me do one thing. Let me make 3 columns, or maybe 4 columns. So let me write man, woman. Let me write man, woman, and let me write man, woman. So first of all, how many men are there? There are 6 men. So let me write 6, 6, 6 over here, and then let me write 4 women, 4 women, 4 women over here. Now the minimum is 2 men and 1 woman. So the minimum is 1 woman, 1 woman, 1 woman, and then 2 men over here, 2 men over here, 2 men over here. Now, if I keep this fixed, and I need a total of 5. That means I need to add 2 more, and that could be the woman. Similarly, if I keep the number of women fixed at 1, I need a total of 5, so those 2 could be from the men. Similarly, if I change these 2, because there is a difference of 2, so let me add 1 over here, let me add 1 over here. Now double check the working. That means at least 2 men, in this case, exactly 2 men and exactly 3 women. At least 1 woman, so exactly 1 woman and at least 2 men will become 4 men. And these 2 are both increased by 1 and 1 because we have the gap of 2 and we are playing it around, either adding a 2 over here or adding a 2 over here or adding a 1 and 1 over here. That's all. So take your time in writing these things down very, very comfortably. So this is 6C2 into 4C3. This is 6C4 into 4C1. This is 6C3 into 4C2. So first of all, let me calculate the first one. 6C2 into 4C3. This comes out to be 60. 6C4 into 4C1, this also comes out to be 60. The last one comes out to be 120. So the total number of options is 60 plus 60 plus 120. That comes out to be 240. That is part A. The second part. The 10 members of the club stand in a line for a photograph. So now, what are they interested in? Now they're interested in arrangements. Before, we were interested in selection, a committee. How many different arrangements are there if all the men stand together and all the women stand together? Now let me make 2 boxes. This is one box. This is the other box. The first box, let me make it for men. How many men are there? 6. 1, 2, 3, 4, 5, 6. How many women are there? 4. 1, 2, 3, 4. In how many ways can the men arrange themselves inside the box? That is 6 factorial on the inside. And what about the woman? That's 4 factorial again inside the box. This is inside the box. And multiply with 2 factorial for the rotation between boxes. So rotation. That means either they will come first or they will come second, and vice versa. So now when we multiply it out, that is 6 factorial into 4 factorial into 2 factorial, this comes out to be 3, 4, 5, 6, 0. That is the answer for this part. Now we are coming to this next part. For a second photograph, what is happening now? Now for a second photograph, the members stand in 2 rows. 6 on the back, 4 on the front. So let me make 2 rows first. So let me choose a different color, a blue color, actually a green color. So there is this one row, and then there is the other row. I can label one of them as the front, and this is the back. So now it says 6 on the back row. So there should be 6 people in this back row, and 4 in the front row, because altogether there are 10 people. Ollie and her sister Petra. So there is Ollie, and then there is Petra, are 2 of the members of the club, and they want to stand next to each other on the front row. So this is Ollie, this is Petra on the front row. Now, how many other people could be on the front row? There could be 2 other people on the front row. And for the back row, as such, there is no issue. So at the back row, I have 1, 2, 3, 4, 5, 6. That is 6 people. That will be 6 factorial, but that will come later on. Now, first of all, if I talk about this OP thing, and let me just remove this thing, and let me draw a proper box. A box for OP. So I'm just working for this. So there is O, there is P, and they want to be together. And then there are 2 people over here. So let me talk about the 3 options. Why there are 3 options? Because among the boxes, they could switch around. So therefore, this is the box is at the front. The box is in the middle. Let me draw a proper box. And the box is at the end. So now we have these options. Let me write OP. So this is O, this is O, this is P, this is P. And then the rest of the people, it doesn't make a difference who they are, here and here and here and here. Therefore, for OP, we should write 2 factorial. This is for OP. And then there are 3 options. So multiplying with 3. That thing is done. And what about who will come over here? Who will come over here? That is 8P2. Out of 8, 2 can come. So therefore, for the front row, this is 3 into 2 factorial for OP into 8P2 for rest. That is the front row multiplying with 6 factorial. So that is the answer. So 3 into 2 factorial into 8P2 into 6 factorial, because 6 are left, they can set according to their own desires and according to their own wishes. And this answer is coming out to be 2419, 241920. And that's how this particular paper is completed. The main thing is show all your working. Do not assume anything. Do not show any unsupported answer from the calculator. Show all your steps with clarity, and that will earn you your A grade and A star. Till the next class, take care.